Algebra 2, lesson 95, more nonlinear systems of equations. I don't know why they just left that off there. I mean, they've got some wordy lessons, you know, like this one. They'll write dependent and independent variables, functions, and functional notation, but then on this one, they didn't want to put of equations. All right, anyways, lesson 95, more nonlinear systems of equations. I'm going to say it. So we're going to be having two equations that we will have to solve using substitution or elimination. What they mean by more nonlinear is more funny shapes like this. Okay. The reason why this matters, it means that we can have more than one answer. And in the case of this nonlinear system of equation, you can have 1, 2, 3, 4 answers. Again, the answers are going to be all the points that the pictures on the graph intersect. So we've got 1, 2, 3, 4 points of intersection, 4 answers to this specific system of linear equation. So let's go over what this can look like. We'll do some practice problems. Starting with this one. Let's say we have 6x minus y equals 5, and then we have x times y. This is different. You haven't seen that. Equals 4. Now, the thing you have to notice is when we have both of our variables being multiplied by each other, like x times y, there's no way I can eliminate xy. So I'm going to have to use substitution. Easiest way to use substitution here, I would say, is solving for y, because it has no coefficient. So let's zoom in here and let's get to work. What's going on with focus? Okay, I guess that's as good as we're getting today. Okay, let's go to work. So solving for y, if I add y to each side, this is going to become 6x minus 5 equals y, right? So all I did is I switched the y and the 5, changed their signs, and I'm going to take this and I'm going to substitute it down here for y. So this bottom equation is going to get rewritten as x times 6x minus 5 equals 4. From here I use some distributive property. I have 6x squared minus 5x equals 4. And you may notice, hey, if I set this equal to 0, I have a quadratic. So this would be 6x squared minus 5x minus 4 equals 0. I do not want to try to factor this. That would be difficult. I can't use zero factor theorem all the time. The best thing to do when you start getting quadratics, use the quadratic formula. There's a reason why we memorized it. So we'll take our a, our b, and our c. We'll plug them into the quadratic formula. So we have negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So if I simplify this, we're going to have positive 5 over 12 plus or minus whatever the square root is. Negative 5 squared is 25. Negative 4 times negative 4 is positive 16. Positive 16 times 6 is going to be 60 plus 36, 96. So plus 96, 25 plus 96, I get 101, 121. So plus or minus, so this is square root. Square root of 121 is actually equal to 11 over 12. So 5 over 12 plus or minus 11 over 12. Now, this is where I have two answers for x. So if I go to my final answer, one of my x values, one of them is going to be 5 over 12 plus 11 over 12. Well, wait, I should solve that, huh? I'm being silly now. Where's my whiteout? I need to make it like this mistake never happened. All right. So, yeah, 5 over 12 plus 11 over 12, like terms, can be added. They even got the same denominator. So 5 plus 11 would be 16 over 12. So one of my possible answers is 16 over 12. The other one is if I did 5 minus, which would give me negative 6 over 12. Okay, so now that I've got two x's, I got to solve for both y's. I could either plug the x's in here, then multiply, add, and then try to get 5, or I can plug them in here. I'm going to plug them in here because it's easy to multiply by coefficient. So the first value I have is 16 twelfths times y equals 4. To solve, I just multiply by the reciprocal of 12 over 16. Whoops. So 12 over 16 4 over 1, so that's 1, that's 4. 12 divided by 4 is 3, so this one will be 3. Now, what if it was the other, negative 12 over, or negative 6 over 12? Hey, that's the same as 1/2. What is going on with me in fractions today? Let's just rewrite this as negative 1/2, and no one will ever know except for us. All right, negative 1/2. That felt like a Bob Ross thing to say, like, oh, I'm just going to cover up this mistake and no one will know except for you and me. Okay, so negative 1/2 y equals 4. Let's solve this one now. Multiply by the reciprocal of 2 over 1. Well, actually, if multiplied by negative 2 over 1, negative times negative is positive, so we get positive y. And then we'll multiply by negative 2 over 1, or just by negative 2. 4 times negative 2 is negative 8. So the other option is negative 8. And then I've got my 2 answers. Cool. Now let's find out what happens if we get 4 answers. So if we have 2 equations that are both squared, like this one, x squared plus y squared equals 9, and then 2x squared minus y squared equals negative 6, I'm going to get 4 answers for this one. First thing I'm going to do here is I can solve by elimination, because I've got x, yeah, these are separate terms, one's positive, one's negative. I'm going to immediately start eliminating. So this will become x squared plus 2x, 3x squared. That goes away. So then 3x squared is going to equal 9 minus 6 is 3. If I set this equal to 0, or actually, you know, I can divide by 3. Do I want to divide by 3? Let me think about it. Yeah, I do. That'll make it super easy. I'll just divide each side by 3. So then I get that. So I have x squared is equal to 1. Oh, this is so easy. If x squared is equal to 1, that means x is equal to plus or minus 1, because square root of 1 is 1. So, in my final answer, I'm going to have 1 where x is positive, 1 where x is negative, and then remember I said that since this one had x squared in both the top and the bottom equations, both the equations are nonlinear, it's very likely that we'll have 4 answers. So what that means is I'll actually have 2 answers for positive 1 and 2 answers for negative 1. That's right, 4 answers. All right. Now I just got to figure out what all my possible y's are. So I can go to, I'll go to this top equation. I'll plug in negative 1. Or we'll start with positive 1. All right, so if we plug positive 1 in here, 1 squared is 1 plus y squared is going to equal 9. So if I subtract 1 from each side, I'm going to end up getting y squared is equal to 8. Find the square root of that. Y is equal to, well, let's see here, hold on, that's 2, 2, 2. That's group, so this is going to be equal to root 2. So 8 is equal to 2 times the square root of 2. So y is equal to plus or minus 2 times the square root of 2. So hey, that's 2 answers for y. Over here, I'll have positive 2 root 2. And then over here, I'll have negative 2 root 2. Hey, I've got 2 of my 4 answers. Now, what if y was equal to negative 1? Well, luckily it's x squared, so let's see here, negative 1 squared plus y squared equals 9. Negative 1 squared is just going to become 1, positive 1, plus y squared equals 9, and then that's the same equation as up here. So it's going to have the same 2 answers. So then down here I've got 2 root 2 and negative 2 root 2. So those are my 4 answers, all 4 of them. And that's it for more nonlinear systems of equations. Not any new math, we're just using it in multiple systems of equations. If you have any questions, let me know on Moodle, and I will see you in class.